All right, so page 9 in your notes. How much will you make next year? So we're going to continue on with this storyline of you are employed and you've got your hourly wage. After much thought, your boss has finally decided on permanent employee wages, which are randomly assigned using the probability distribution X given below. That would be this table here in number 1. Additionally, at the end of the year, everybody's going to get a raise. Everybody gets an hourly raise added onto their base wages, and the pay raises are also going to be randomly assigned, shown in the distribution here for Y. We're going to assume that X and Y are independent. I want you guys, for starters, to do numbers 1 and 2. Find the mean, the standard deviation, and the variance. Remember, variance is just standard deviation squared. So use either the app on your cell phone or grab a graphing calculator from the back. I want you to find the mean and standard deviation of X, and then calculate the variance, standard deviation squared, and then do the same thing for Y. I'm going to give you guys about 3-4 minutes. After you have these pieces, if you want to compare with people around you, please feel free. Those statistics for you. Stat calc is one variable because we're only looking at that starting Yes. Just clear. So let's go and highlight the names list. That we just entered in. You're welcome. Again, we want mean and standard deviation and variance for X, mean, standard deviation, and variance for Y. But then, yes, those things that you were pointing to, absolutely, the parts that you want to be looking at. Done. After you have found your mean, variance, and standard deviation, if you want to compare it with somebody around you, I want you to do this for both X and for Y. If you don't remember how to do this on the graphing calculator, please make sure you raise your hand so I can come around and help you with that piece. You guys about ready to check these? All right, let's go ahead and check these out. For the mean for x, you should have gotten 1185. Remember, we represent that with mu sub x. Standard deviation, you should have gotten 222 when you round. If you got 221 because you didn't round it up, that would be fine. That would be sigma of x. And then the variance, which you take by doing the standard deviation and squaring it, multiplying it by itself. So that would be sigma of x squared. You should have gotten 4.93. And then for y, the mean was $1.60, so that would be my mean of y, mu of y. Standard deviation is 92 cents, so that's sigma of y. And then my variance is sigma of y squared, and you should have gotten about 84 cents for that. If you took it out to more than 2 decimal places, that's perfectly fine. I rounded to 2 decimal places here since we were talking about money. That's what made sense in this context. So far, so good? All right. Let's go and look at question number 3, which is the rest of the front side. We're going to let N represent the new hourly wage for the upcoming year. So everybody starts with their original base wage of either 9, 12, or 15. And then they're going to get that raise of either $1 or $3. So what are all of the possible wages these employees could be making in the new year? 10, 12, that would be $9 plus the $1 raise, $9 plus the $3 raise. So 10, 12, 13, 15, 16, and 18. That's $9 plus the $1 raise, $9 plus the $3 raise, $12 plus the $1 raise, $12 plus the $3 raise, 15 plus the $1 raise, and then 15 plus the $3 raise. That's how we got those numbers. Remember up above, it said that X and Y are independent. I want to calculate the probability of getting a $9 wage and a $1 raise. Think back to what we did in chapter 5. How would you calculate the probability of the and here? Multiply. What are we going to multiply together if I want the probability of 9 and a $1 raise? Probability. So tell me what numbers I'm multiplying together. 0.3 and 0.7. Because this is the probability that somebody makes $9 an hour. This is the probability that they get a $1 raise. And what do you get when you multiply 0.3 and 0.7 together? You should get 0.21. So what's the probability of getting a $9 wage and a $3 raise? Think about how we did the one up above. $9 starting salary and a $3 raise. 0.09. We would take the probability that somebody makes $9 an hour, which is the 0.3, times the probability that they get a $3 raise, which is also 0.3, and we get 0.09. All right. We are set up now to be able to make a table for our new random variable n. Remember, n is my random variable x, the starting wages, plus y, the raises. What were all the possible values for n again? 10, 12, 13, 15, 16, and 18. What would the starting wages have been for somebody that's now making $10 an hour? They originally made $9 and they got what kind of a raise? $1. So $9 an hour starting wages and a $1 raise. What's that probability? 0.21. What we did up above. How would somebody end up making $12 an hour in the new year? What were their starting wages? What was their raise? 9 and 3. What's the probability that somebody had 9 and a $3 raise? 0.09. I want you guys to finish out the probabilities on this table. Think about how we got these numbers and apply that for the rest of these. What would somebody's base wage be? What would their raise be if they're now making 13? What would somebody's base wage be? What would their raise be if they're now making 15? After you finish filling in the table, I want you to calculate the mean, the standard deviation, and the variance for our new random variable n. Don't round your probabilities, by the way. Don't round the probabilities. They're coming out to 3 decimal places, some of them. Write down all 3 decimal values. What's the probability somebody makes $13 an hour in the new year? 0.315. That would be that 0.45 times 0.7. What's the probability somebody makes $15 an hour in the new year? 0.135. $16 an hour? 0.175. And $18 an hour? 0.075. And then we take those new those new values for n, we put those in list 1. We take the new probabilities, we put those in list 2 to find the mean and the standard deviation. What did you get as the mean for our new random variable n? Got 13.45. What'd you get for the standard deviation? 2.40, $2.40. How do you get the variance again? Take the standard deviation and square it. What's the variance? About 5.77, 5.76, depending on exactly how you rounded it there. I want you guys to spend a minute or two. I want you to look at the mean, look at the standard deviation, look at the variance, and I want you to figure out how you could get there based on the mean, standard deviation, and variance for x combined with the mean, standard deviation, and variance for y. Because this, our random variable n, is x plus y. So figure out what you would do with the means to arrive at this new mean of 1345. What would you do with the standard deviations? What would you do with the variances for x and for y to end up with this new mean for n, this new standard deviation for n, and this new variance for n? I'll give you guys, like I said, about 1 or 2 minutes to look at that and see if you can find a pattern. If you get stuck on one and you can't find a pattern there, move on to one of the other ones. What would you do with the mean of x and the mean of y to get this combined mean? Add them together. The means add. So a general rule that I could use for that, to find the mean of my combined, we take the mu of x plus the mu of y. Was anybody able to find a pattern for the standard deviation? You divided them? Is that what you found too? That might work here. On this example, it doesn't work across the board. What about the variances though? We'll come back and talk about standard deviation. Did you find a pattern with the variances? What'd you do there? Add those. So the variances add. This is sigma of x squared plus sigma of y squared. How did we find the variance again? Like not just on this one, but what did we do on each of these to find the variance? We took the standard deviation and we squared it, right? Well, I've got this really easy rule for how to find the new variance. I take the old variance from x, the old variance from y, I add them together. So what could I do then to get the standard deviation, do you think? I can square root that. So I'm going to take the variance, sigma x squared plus sigma y squared, and I'm going to square root it. This does not add. But the variance does. Means add, variances add. To find the standard deviation, we'll have to find the variance, add them together, and then square root it. That will work every single time. You guys ready to flip this over? Cool. So yesterday we talked about adding and subtracting a constant with a random variable. We talked about multiplying and dividing a constant with a random variable. Today, we looked at combining random variables. We looked specifically at this situation where we were adding our random variables together. To find the new mean, you add the old means. To find the standard deviation, you add the variances and then you square root it. We can use a similar pattern when we want to subtract our random variables. Seems to make sense that when we subtract our random variables, we subtract our means. When I add the random variables, I add the means. When I subtract the random variables, I subtract the means. Here's a weird piece though, and I need you guys to make a note on your page about this. Look at the variance formula, or sorry, the standard deviation formula. What do you notice? It's still adding. You do not subtract the variances. Ever, 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 ever. The reason for that, when I take distribution A and I take distribution B and I combine them together, my spread, my variability gets bigger. Even if I combine those two things by subtracting them, the overall distribution is going to get more spread out, not less spread out. If we are looking at normal distribution calculations, so I want to combine two normally distributed random variables. I either want to add them together or I want to subtract them and find their difference. We're going to use the formulas over here on the left-hand side, depending on whether I want to add them or subtract them, to find the new mean and the new standard deviation. And then we're just going to go forward like normal with our normal distribution, normal CDF, lower bound, upper bound, mean and standard deviation to calculate this. Let's look at the check your understanding. I want you guys to do just numbers 1 and 2 for right now. Hold off on number 3. I'm going to give us about 3 minutes to do number 1 and number 2 only. If you need help with the interpreting the mean on number 1, flip back a couple pages because we interpreted the mean a couple pages earlier. I think it's like 2 pages back. Use the formulas from up above to help you calculate the new mean and the new standard deviation. And then I want you to interpret the new mean. What's the mean of our new random variable D? 2 point what? 2.08. The mean of D is 2.08. You took the mean of X, which was our home team, minus the mean of Y, which was the away team. We get 2.08. What does that 2.08 mean? How would we interpret that? A mean is also an average. Short-term average or long-term average? Long-term average. So after many what's? Games, after many football games, if I'm looking at we have X minus Y, what does that mean? We've got the difference of home team versus away team. So after many football games, the average difference between home team and away team points is about 2.08. What's the new standard deviation? $13.23. Absolutely. You take the standard deviation for X and square it. You take the standard deviation for Y and square it. You add them together, and then you square root that sum. That's how we got the 13.23. Yes. Yes, I can go back. Give me just half a second. I want to make sure that I don't have to come back to this one too soon. All right. You guys okay if I go back to the last slide? Okay. If you were still working on getting this interpretation written down, please feel free to snap a picture. So far, so good on how to find the new mean, how to find the new standard deviation. All right, let's see if we can apply this now. How did it say both of these were distributed? Approximately normally. We just found the new mean and the new standard deviation, right? So do I have enough that I could start to draw a picture? We're going to draw a normal curve. Draw that on your page. What should go right down the center of the curve? The mean, which is 2.08. You need to label this. This is what kind of distribution? Normal, so you're going to put a big capital N. What goes inside the parentheses next to the N? Mean of 2.08 and standard deviation of 13.23. Then we have to figure out our lower and upper boundary. Yes, sir. Where's the what? Where does N go? You're going to put, let me, so draw your normal curve and then you do a big capital N next to it like this. We don't know our lower and upper boundaries yet. So we can't do normal CDF yet, but let's read through the problem here and see if we can figure out what our lower and upper boundaries should be. I want to know the probability that the home team has more points. Which distribution represented the home team, X or Y? X. So Y represented the away team. If the home team has more points, and I subtract these two things, what kind of number will I end up with? I'm going to end up with a positive number. If the home team has more than the away team, and I minus those, I'm going to get a positive number. Positive numbers have to be bigger than what? What's the dividing line? 0 is my dividing line between positives and negatives. So if it's a positive number, it has to be bigger than 0. So what we're looking for here is the probability that x minus y is bigger than 0. I would like for you guys to finish out your picture. So add your lower and upper boundaries, add your shading, and then I want you to calculate the probability that x minus y is greater than 0. We'll check back in about a minute and a half, 2 minutes. Let's compare pictures. Your picture should look something like that. 0 is somewhere to the left of the mean. As long as you have it labeled, it's okay if it's not exactly where it would fall. You've got it labeled on there. You're saying what the mean and standard deviation are. Now, how do we calculate the probability that x minus y is greater than 0? What function do I need to use? Normal CDF. What are the parameters that I need? I need 0 as my lower boundary, a big number for my upper boundary. What do you think would be an appropriate big number? If you take home team and away team of football teams, like one game, and you subtract those, 200 would definitely be big enough, right? If you go with 1,000,000, would that be? Yeah. 100? I mean, even in a high-scoring football game, if the away team just absolutely gets decimated, it's still probably not going to be more than 50, right? The difference in their points. So going with something like 100 or 200 would probably be fine. And then we want our mean and standard deviation in there. So it should look something like this. And what'd you get? Point what? 0.56. I would take it out just a little bit further. I would go at least to 3 decimal places on this. But I got 0.5625. If you were asked to interpret this, what does an answer like this mean? Let's read it left to right and help me interpret this. The probability that the difference between home team and away team points is greater than 0. Or you could say the probability that the home team has more points is about 0.5625 or 56.25%. So of all the games that they collected, if I were to randomly select one of those games, the probability that the home team scored more than the away team is about 0.56. So far, so good? All right. Homework's due tomorrow. If you look at that homework, we've got 3 questions on the front side. The first question has parts A, B, and C. Part A goes from yesterday's lesson, like straight out of yesterday's lesson. Part B is today's lesson. Part C puts them both together. And then you have 2 other questions on the front side that are like this right here. They are normal distribution questions. On the back side, it's basically a repeat of the front. The top question on the back side is just like the top question on the front side. And then you've got another normal distribution question on there. All right?